Welcome. This is going to be covering a lesson 5-5, inequalities involving absolute values. So the first scenario that you have is your absolute value inequality that has the less than symbol in it. Here's the example. So the inequality absolute value of x is less than 3, that means that the distance between x and 0 is less than 3. Because remember, that's what the absolute value refers to, the distance between that value and 0. So when they say here it's less than 3, here's a visualization of that. So when they say x is less than 3, you're talking about a distance in which the x is less than 3. So it's open here on 3 and it goes all the way down. And right here when it's negative 3, it goes all the way to right because you can plug in negative 2 in here. What's the absolute value of negative 2? 2, which is less than 3. Do you see how the absolute value refers to the distance from 0, and that is where all the values of x that is less than 3 or greater than negative 3. So if you put that in your inequality, it looks like this. We would say that x can be less than 3, right? 2, 1, 0, but it has to be greater than negative 3. Right? It can't be negative 3. It can be negative 2, negative 1, 0, right? So these are the two solutions that exist from this one absolute value. So when you have two solutions, we call that a compound inequality. And because it's a compound inequality, you combine the two solutions. So this x is greater than negative 3 and x is less than 3 can be put into the solution set of x. The solution of x can exist less than 3 but greater than negative 3. Okay? So, here is example 1. It says solve absolute value inequality, and it says solve each inequality, then graph the solution set. Here you have A. Absolute value of m plus 2 is less than 11. Remember, there are two solutions, okay, because of the absolute value. There is one where the absolute value, where m plus 2 is less than 11, then also m plus 2 is less than negative 11, okay? Like this. You see how there are two solutions here, right? Alright, so if you put this into compact form, oh, this is actually flipped. Yeah, this is actually flipped. Okay, because of its negative. So do you see how this in compact form would look like this? M plus 2 have to exist less than 11, but greater than negative 11. Do you see that? We would say that this absolute value, m plus 2, has to be less than 11, but greater than negative 11. Okay, this symbol here is off. So, you put it into the compact form. M plus 2 is less than 11, but greater than negative 11. Subtract 2 to both sides because you're trying to get m alone. Then you get negative 13, which is negative 11 plus negative 12. Then on the right hand side, 11 plus negative 2, that is a 9, right? Simplify this because you never write that plus 0. We would say m is less than 9 but greater than negative 13. Your solution set would be m. M exists less than 9 but greater than negative 13. If you put this in your graph, do you see how it's less than 9? It's open here on 9. It goes all the way down, but it has to be greater than negative 13, which is going all the way to the right. The beauty of this is that it's in the compact form. Okay? So let's do 2. Okay? Can the absolute value negative 11 be less than negative 2? The solution is actually the empty set, right? No solution. Remember, that is what the empty set is. The solution is the empty set because the absolute value cannot be less than negative 2. Remember that the absolute value represents a distance away from 0, and you cannot have a distance of negative 2. Alright, what I would like you to do here is pause the video and attempt to do 1A and 1B. Solve each inequality, then graph the solution set. Now I'm going over the solution for the guided practice. 1a, you have n minus 8 is less than 2. So here's your original absolute value. And this is what it looks like in compact form, because again, when it's less than or equal to in the absolute value, we can put it into a compact form like this. Because again, there are two solutions. Your first solution is n minus 8 is less than or equal to 2. Then you get n minus 8 is greater than or equal to negative 2. Add 8 to all sides of the expression. Negative 8 plus 8 is 0. 8 plus 2 here is 10. 8 plus negative 2 here is 6. Then you can simplify. Okay? N is less than 10 because that is 8 plus 2. And 8 plus negative 2 is 6. So n is less than 10. N is less than or equal to 10, but greater than 6. So this is what happens when you graph. It's closure on 10 and it's closure on 6, right? The values of n has to be less than or equal to 10, but greater than 6. What about 1b? You should notice something. This is the absolute value. Absolute value of 2n minus 5 is less than negative 2, negative 3. The solution is the empty set because the absolute value cannot be less than 3. Remember that the absolute value represents a distance. Next scenario. The absolute value greater than. What about, now I'm changing the sign. What about if the inequality x, the absolute value of x is greater than 3? What does that mean? It means that the distance between x and 0 is greater than 3. Remember? Listen to that. The distance of x has to be greater than 3. So, right, anything to the right past of 3 is greater than 3. 4, 5, 6. What about down here, right? Negative 4, negative 5, negative 6, and so on will have a greater distance to 0, right? It's greater than 3. So, what does this remind you of? This looks like, remember to change the inequality, that x is less than negative 3. That's why it's going to the left. And x is greater than 3. That's why it's going to the right. Remember, ooh, this is wrong. This is not the intersection. This is actually the union. This is the union compound inequality. The solution set is x is less than negative 3 or x is greater than 3. Remember, this is wrong. This should be union, not intersection. Sorry about that. So let's do example 3 to give you how it applies in the problem. Solve absolute value of 3n plus 6 is greater than 12. Here's the absolute value of the inequality. Notice that there are two solutions, but we cannot put them in compact form because this is the union. Alright, here's your first solution. 3n plus 6 is greater than or equal to 12. Subtract 6. You get 3n is greater than 6. Divide 3 to both sides. N is greater than or 2 after you simplify. Here's your second solution. 3n plus 6 is less than or equal to negative 12. Remember, you change the direction of the inequality when you have the negative here. You see, this is positive 12, but I made it a negative 12 because that is the second solution. So you have to change the direction of the inequality. Subtract 6 to both sides. You get 3n is less than or equal to negative 18. Divide 3 to both sides. You get n is less than negative 6. So the solution set, like before here, is n is greater than or equal to 2 and n is less than or equal to negative 6. Right here, so we could put that in the solution set. N is greater than or equal to 2 or n is less than or equal to negative 6. Here is your solution. Here's your solution set. It's closure on 2 because n is greater than 2. greater or equal to 2, and n is less than or equal to negative 6. That's why it's closing on 6 and it goes all the way to the left. What I would like you to do now is do the guided practice. Solve each inequality, then graph the solution set. Okay? You have 3a here and 3b here. Remember, these are all unions. Okay? Please pause the video and attempt to do the problem. 3a. Notice that it's the absolute value inequality. There are two solutions, but we cannot put this into compact form. Their first solution, 2k plus 1 is greater than 7. Subtract 1 to both sides. It becomes 2x is greater than 6. Divide 2 to both sides. Then you get k on the left hand side. 6 divided by 2 is 3. So k is greater than 3 after you simplified. Your second solution, 2k plus 1 is less than negative 7. Remember, it becomes a negative 7 because that is the second solution, and you have to change the direction of the inequality. Subtract negative 1 to both sides. You get 2k on the left hand side, you get a negative 8 on the right hand side. Divide 2 to both sides. You get k on the left hand side, negative 8 divided by 2 is negative 4, and that is on the right hand side. So your solution set would be k. K is less than negative 4. But, no, k is less than negative 4, and k has to be greater than 3. So, again here, it's open on 3 because it has to be greater than 3. It goes to the right. K is less than negative 4. So it's open here on 4 and it goes all the way to the left. What about 3b? Absolute value of r minus 6 is greater than or equal to negative 5. Notice that the solution is the empty set because the absolute value cannot be less than negative 5. Remember that it cannot be greater than negative 5. Remember that the absolute value is a distance. You cannot have a negative distance. There you go.